No, so this is a soft launch for the data engineering practice. I want to talk a little bit about sort of the way that data engineering is converged. But first, I want to give just a little fun anecdotal story about when we were a wee company about 8 years ago. I had started the business doing just random odd jobs. It's kind of what happens when you start a business. You take whatever you can find. And some of my friends that worked at a local automotive company here in town had called me, a guy that I knew that was a great human being by the name of John Smithson. If he ever watches this, I owe you a debt of gratitude. But he called me because one of his engineers was leaving, and this guy was a smart guy and was known to duct tape and Bondo things together, although he'd throw a rock at me if he heard me say that. Most of the things that he built were fine. They worked perfectly fine. They were built in ancient technology, which was maybe a bit of a difficulty for me, but I like a good challenge. And when I hit the ground, this particular organization was an operational analytics organization for an automotive auction. So little bit of a different problem. One of the fun things about being a software engineer and also just being a consultant is you get to do all kinds of things. You're not just stuck to working on this target platform or this thing or this product, this SaaS API that has a set no number of problems, and you're pushing features or you're dealing with operational issues and CI/CDing stuff into production, et cetera. Which again, that's fun too, but that's a different kind of fun. One of the chief things that this particular organization did, it was a little bit of a shadow IT shop, but they produced operational analytics for auto auctions. And auto auctions are a very interesting problem when you're thinking about what they do, right? So they take fleet cars, they take vehicles that have been leased by you and me that were returned to the dealership, and the dealership didn't really want to keep it because it was frankly not worth enough money to keep it around and try and sell it. So instead, they sell these things on auction. And fleet cars, Hertz, rental cars, all these places will sell these things on used cars too to other dealerships. Like the mom and pop dealerships, like the Gravity Autos of the world, and they'll buy these cars and they'll sell them back to people and make a little bit of money. So it's a nice market for used vehicles and for leased and fleet cars. So this particular an auction, as you're sending a car through, there's a lot of data that has to be captured about a particular car. One, the condition reports, how well they operate, how does it crank, does it still run? Because believe it or not, some people will auction off just bodies and cars that aren't fully functional. At least they did back then. And this particular business was all run on ancient IBM hardware, this mythical thing called an AS400, if anybody knows what that is. And the cool thing about it is that these AS400s are kind of like these specific ecosystems that sit there and collect data. They have a DB2 file system. Well, it's a journaling file system, excuse me. And it's kind of like DB2. It's different. I don't know the exact name of it. I didn't get that deep into it, but I did get to play with these things and learn how to interact with them and pull data. So my first gig at Seven Factor, my first fully sold contract was more or less taking an existing set of applications that were built on top of these AS400s and a data warehouse and rebuilding the warehouse, recreating the data, excuse me, in a way that it could be accessed by analysts, by operational analytics analysts, and that also provided value back to the operators of these individual auctions. So there were a set of tools that the student had written that were interfacing and doing ETL, pulling data out of these AS400s and putting them into local databases, doing aggregate tables, doing fact and dimensions, and sort of all the stuff that you kind of hear about in the modern lake house slash the modern world. And back then we were still all doing kind of Kimball style star schemas, if anyone remembers what that is. Um, but the cool thing about this gig was that I didn't know what I was doing at the time. I was a software engineer by trade. I had left another consulting firm to do my own thing, and had spent most of my career building data and building backend systems. Excuse me, not data, building backend systems, APIs, etc. And that was my trade. But the thing that I liked the most about building APIs and doing production systems was the data stuff. I'm a backend guy. I can't stand JavaScript. Sorry, hate me. I hate it. It's just not me. I don't like pushing pixels and making pixels pretty. I prefer the backend stuff, parallelism, distributed systems, data. That was where I really gravitated because I like it more. It for whatever reason, clicks with my brain better. Um, and I enjoyed the time there and I learned a lot. I taught myself, again, John, if you're reading this, I pulled one over on you. I taught myself a lot of data engineering techniques when I was on the ground doing this, which is common for a consultant, right? It's no secret that consultants and that people that you hire on contract oftentimes don't know everything. They have to go and learn things, and that's one of the reasons you hire people that are smart and that do consulting work is because we can learn very quickly. It's part of the job. Part of the job is learning, right? So I took these 400s and I rebuilt the what I would consider, frankly, to be a data warehouse or a lake house in some ways. It wasn't like a traditional EDW. This company had a traditional EDW that was being built by a different consulting firm. As for all I know, they're still there doing it because I think the project was on year 6 or something like that of building the EDW, the holistic, gigantic EDW of every transaction ever in a factor or dimension, central. Which I mean, the data world has very much diverged from that. Thank God where we're not doing that anymore. We're thinking in terms of even the medallion architectures, which are interesting, which is all of the data at the bottom, and then you create aggregates in the silver tier and the gold tiers where you ask your business questions and you build your semantic layers and your Tableau dashboards and stuff. So it's vastly changed from where it came from, but. The time that I spent there, I learned Kimball style star schemas. I learned ETL, which the funny thing about ETL and ELT is they're both a function of good software engineering practices, which is one of the things I want to talk about and to discuss why we as a company, Seven Factor, has decided to launch sort of data engineering as a thing we do. Frankly, we have roots in it. I did this. It was the second contract I ever won, was creating a sort of pseudo EDW, pseudo lakehouse on top of operational data, which was real time data for these automotive auctions. And a lot of the things I was doing, I didn't understand. I didn't know this idea of streaming in real time, which I mean, you can't really do streaming on a 400. Um, but this concept of real time data, this concept of what's the periodicity of your data, how are you pushing that, how are you transforming that, what's your data governance strategy, how are you thinking about ensuring that the models are appropriate, and what's your semantic layer on top of the models, what's OLTP versus OLAP. They were actually doing some cubes at Mannheim. So I got experience to all of these sort of 3-dimensional, 4-dimensional kind of data type stuff that I really enjoyed doing. And then moved on from that gig and continued to build this company. And fast forward to the past 2 years, we've done, I would say, at least 6 or 7 projects on our docket that I technically would consider data engineering. We did some work for Delta back in the day that was working on some of the data inside the tech ops hangar and building out some ETL practices for an HRIS system for nursing. So we've done a lot of stuff that sort of cross cuts the data world. And one of the things I want to think about today is in what ways in celebration of us launching this offering, in what ways has software engineering and data engineering really converged? And what are the specializations? Again, Conway's Law, for those of you who remember what Conway's Law is that the organization is going to more or less organize itself around the functions and the types of things you're trying to solve for, the business problems you're solving, right? Your organization will match that. Um, and there's sort of two cultures in data engineering and software engineering, two definitions of what done means, and there's sort of two, but the way we solve these problems is more or less the same now. 4 or 5 years ago, everybody was using Informatica, Talon D, and I know some people are still using Informatica and Talon D, but most of the modern data stacks that I've seen, which has been popularized by Snowflake and Databricks and all these bigger sort of behemoths in the room these days, are all Python driven software engineering ideas, right? So when you're building an ELT or an ETL pipeline, you're thinking in terms of DBT, you're thinking in terms of Panda data frames, you're thinking in terms of Spark and PySpark and Java Spark jobs to do MapReduce stuff or to do like really heavy movement of stuff. Now we've got Airtable, we've got some other really cool sort of DAG-based systems that will solve some of the orchestration problems that stuff like Informatica was solving. Because if you think back to 5, 10 years ago, the big challenge was how do I order my jobs appropriately? And DAGs are, great idea, computer science idea to use in order to solve for that problem. I think Terraform might have had a hand in making DAGs useful in the world, apart from they're just useful as a software engineering construct. So I think that the big thing that I'm excited about as as data engineering moves more into software engineering is the types of patterns and practices that we can put in play, right? Data is now product critical in many ways. There are plenty of companies out there that just sell data. That all they do is collect information and sell it. I would say that Google is pretty much that. But there are lots of other companies, social media companies, that's all they do is they collect data and then they sell it or they provide insight on that data in some way. And most products, having insight on your data is one of the key and critical things that you want to be doing, right? There's a few customers that we have that I've had those conversations with is like, look, your goal, yes, you're a SaaS product. You solve business problem X, but look at all of the information you're collecting about business problem X. The next step for you is to think about monetizing that data and turning that either into better insights and analytics for your existing customer base, better operational insights into how your business runs, how people interact with your business, how your cloud is running, what's the cost and the expense of that. But again, that's kind of a smaller piece. A lot of people think of the operational data as like the gold mine. It's really not. The gold mine, the people that have made the most money and elevated their companies the highest through their data is thinking about how do they serve their customer better? How do they monetize that data? How do they turn that into a better product offering? And machine learning, there, I said the buzzword of the day, is actually a really fantastic way to do this because, again, classification problems, if you have a classification problem in your industry and you have data to throw at that, at a classifying algorithm or a CNN or something like that, it's a really good idea. You can turn that into a product. You can turn that into business value by simply taking all this data that you've already collected, putting it into a format that you can monetize, which is again using a lakehouse structure, using medallion architectures, whatever you choose. There's plenty of products on the market, some of which I frankly don't know. There's a lot more advanced stuff out there, and that you can use to pivot your business or perhaps find again additional insight that you can use to monetize. Um, the cloud also is, I think, put a big asterisk on data engineering and that infrastructure isn't a problem anymore. I remember back in the day when I was at that automotive company, I had to talk to an entire database group to get an Oracle database. And it took weeks and weeks and weeks to get an Oracle database. And then they wouldn't really let me do any modifications to the schema without getting it approved. Traditional old school enterprise stuff that just takes forever to do things. They're different now, but back then it was the right thing to do. It was how they chose to do business and to protect the precious, which is their data. So nowadays, it's very easy to throw your data into a Spark instance in Amazon or in GCP, or even using amazing products like BigQuery, which already have a lot of insight baked into it and a lot of the sort of UX expected out of a data platform already there. Snowflake is the big giant gorilla in the room. It's a fantastic platform. Nothing but good things to say about it. Databricks is good for ETLing. There's plenty of other ones out there. I would even dare say that Informatica and the old school, who I'm calling the old guard these days, are doing a great job of innovating in some ways as well around ETL and ELT platforms. But the cloud was a huge thing that also unleashed, similarly to how it unleashed software engineers to being able to decouple their lives from the operations folks, but it also allows data engineering to do some pretty cool things and to spin up environments and lake houses pretty quickly, which is different than how it used to be. So what I'm kind of seeing these days, and the reason that Seven Factor is moving into data engineering is there is a collapsing, I think, of the skill sets that are required to do data engineering and to do software engineering. The ideas of iterating quickly, fast feedback loops, delivering things into production using CI/CD, building building reverse pipelines, right? Where you've got, say you've got an ELT that you want to backport, or say you've got excuse me, a CRM or some data product, Workday, something like that, and you have this vast enterprise data warehouse over here. Data is being piped into your enterprise data warehouse. Now you want to sync that back to Workday or something without creating a loop. Like there's all kinds of software engineering problems that need to be solved. Event-driven architectures, streaming is a big thing if you've worked in Kafka or Kinesis. These are very software engineering focused skill sets, and a lot of the best data engineers that I've worked with have that similar mindset, and that I'm here to solve problems iteratively. Like I may have an expertise in product A, B, C, or X, Y, and Z, but applying a more software engineering centric problem solving ideology to your data problems, I think is also a great way. And most world class data engineering organizations, this is what they do, is they don't really care where you came from. If you were a software engineer, you'll make a great data engineer. And if you're a great data engineer, you'll probably make a great software engineer. It's just about learning the different problems that you have to solve for. In addition to that, like there's there's a huge Venn diagram between the tool sets that I've seen these two competencies use. Everybody's on Get now, which is fantastic. Version control pipelines. Something that I was doing for a long time is migrations and checking in data modifications for my transactional sources into Git via a seed schema file or something like that. A DDL is what they called them back in the day. Not just application code anymore. You're actually shipping a lot of data, definitional data modeling code as well, which I think is software engineering workflows apply very cleanly to that. CI/CD is a thing, obviously, for your pipelines. Some tooling does this better than others. There's great thing. Prefect is a fantastic tool that is an ETL platform that allows you to kind of plug into Git for your Python workflows. There's a bunch of other ones out there that do a great job at that as well. Unit testing and data quality checks are another big thing that we want to focus on. Infrastructure as code. Obviously, we've already talked about CI, or we've already talked about the cloud sort of unleashing their capabilities. So each of these four components are key to being a good software engineer, and now they're also key to being a good data engineering, building a good data engineering organization. This other interesting data concepts that I've used in software to, again, draw the Venn diagram: schema design, evolution of the schemas, as we said, DDLs, making those nice and clean and ensuring that your migrations are appropriate. You've got the right indexes in place. This is what, DBAs used to do. We used to call on the DBAs to come look at indexes. These days, I don't do that anymore. I do them myself. Is it because I'm a DBA? No. Do I know the ins and outs of every single database system? No, I don't. There are certainly specialists that you need to call when there are specific problems. But do I understand how to put a simple index on something that's got a high concentration of where clauses? Absolutely. And these are things that I think software engineers and data engineers share, and they should know. There are probably some data engineers that don't quite understand indexes properly. Indexes are great. B-spline indexes are really fun. I've done lunch and learns internally talking about how they work. It's really cool. The data structures are nice and interesting to think about. And then when you get into sharding and you get into the more distributed systems, it gets even more difficult to really kind of grok that. So definitely there's some specializations on each side. Just like I wouldn't necessarily have a data engineer understand the depths of threading and CSP and channels and all this and that. Wouldn't necessarily want a software engineer to have the depth of understanding of how like partitioning works and CAP theorem and things that data engineers care about. Um, Data contracts between services is another piece that's very important. You've all done this if you're a software engineer. You've absolutely sat down and talked about a data contract, and that is a data concept. It is a data engineering idea. Granted that your physical table structure doesn't necessarily have to look exactly the same as your JSON, but you still want to think about nouns and verbs and how those things relate to one another. Event modeling over request response, that's another big thing. Data observability, stateful systems. You have to have persistence in order to have a service that stores state, et cetera. So these are all data ideas that have invaded software, and it really kind of makes the two things sort of very Venn diagrammed, which I appreciate. And in my head, what does a data engineer do? And why do I think Seven Factor is a great pick, and the company that we've built and that we spent all this time making a name for ourselves in software engineering? Why do we think that data engineering is a great thing for us to move into? Well, one, we understand distributed systems because we built distributed systems on the API side. We've created we've worked with and created in real time streaming systems. We built some really big production grade. I'm talking like dealing with large amounts of data, backend API services. So it makes perfect sense for us to apply those engineering skills on at scale, on data at scale from the application side to also data at scale on the warehouse side, right? I think that the old school of a SQL only data analyst is not going to be around for a long time. You've probably in your organization, you may have folks that are more focused on that, but they need to be likely upskilled and moving more towards writing code and doing Python, especially in an AI world, right? And be careful with this, but Claude can certainly write ETL pipelines like that for you. Again, you have to be careful and make sure that it's not piping garbage and Johnny drop tables and all this. But in a world where learning is 10 seconds away by having a conversation with the model, not the machine, but with the model. Remember, you're talking to a model, you're not talking to a person or a thing. Uh, that should alleviate any of the stress that you might have on building or on upskilling folks in your organization to do the more sort of software engineering type things that you see data folks do these days. I would say some of the specializations that you might find in a data engineer, especially coming from us, or that I would want in a good data engineer, is that there is an understanding of data modeling there. That is one thing that software engineers don't typically do a whole lot of, unless you're building greenfield from the ground up. And there's gaps in knowledge there. I mentioned earlier understanding of indexes and things like that. I happen to have that understanding because I really enjoy data, and I've spent a lot of my career building large distributed backend systems with that, with my earlier story as well. But that is a gap that you want to make sure that you're filling properly with expertise on the data side, and that we're doing by hiring in true data engineers and people that have worked in these platforms at scale, is folks that understand production grade systems and understand lakehouse models and understand things like Delta Lake and Airflow and all these other tools. I have no problem snagging a software engineer off my bench and putting them, up against something like a Python-based ETL pipeline with the right oversight and the right set of ideas on that. Here are the do's and don'ts of how you do that. I think there's no issue with the Venn diagram and the overlap between a software engineer and a data engineer doing that work. When you do get into the more architectural stuff, when you get into the right way of designing things, medallion architecture, stuff like that, I would say that that's definitely something that you want a specialist for. And we've started hiring in those specialists. We actually have 3 gigs right now that are all data engineering focused, and we're very excited about continuing to expand our business in that way, because the level of rigor that we bring to software engineering applies very cleanly to the level of rigor that you need in data engineering. Because again, data is monetized very simply, both from a product and a platform perspective, but also just in general. From how you put that data into production is important as well, and making sure that you're doing that in the right way. So I think that couple of anti-patterns we want to talk about. Sorry, I'm kind of shifting gears here, and then we'll kind of wrap this up with sort of the final pieces here. There's a couple of anti-patterns that we typically see, people that we want to avoid in the data engineering world, and these are anti-patterns you can actually really see anywhere. And these are things that we're teaching our folks not to do. One is pipelines as simply scripts with no error handling, tests, or ownership. This was the ETL data in that gig that I talked about at the beginning of this conversation was a Windows task scheduled job that ran with VB script, not VB.net, VB script. So we're talking super old school here, and used ODBC to connect to these AS400 machines over one single Windows box that was literally on someone's desktop. I know that that's kind of a meme these days, but it was real. And there was no error handling. There was no tests. There was certainly ownership, but it was one person that left, and now everything was broken. And I received calls, and still to this day, last year, got a call from that client asking me, "Hey, we inherited some of this stuff and we don't know how it works. What is the deal with this thing?" So it's important to avoid treating your pipelines as scripts in modern day, which is a thing that we we've done for a long time because again, data engineering has been sort of duct tape and bubble gum or informatica or whatever. Nowadays, it truly is a software engineering art, and you want to apply good software engineering techniques to it. You want to make sure you have good error handling, retry logic, batching, batch IDs, correlation IDs, passing correlation IDs through multiple jobs, or just hell, just use Airflow or use DAGs to solve those problems for you, so you know exactly when your data is coming in, what the timestamps on those data are, what's the lineage of that data, what are how do you manage deltaing, like all of that's very important today. CI/CD is a thing that should be everywhere forever and ever. Amen. We should not be copy pasting scripts onto boxes like I was at that gig. Again, Windows Task Scheduler with VB Script. I introduced Git, and I would check things into Git, and I would cut PRs, and then I would do a Git pull on the machine. That's how I would deploy. That's all I had access to back then. So that gave me a semblance of kind of CI CD-ish, but I was the only guy on the ground, so I didn't really have PRs or anything like that. But I think in today's world, it's important to use best practice on the software engineering side, having CI/CD for your schemas. Like I love to check in migrations for schemas and changes, especially if you're in a compliance-oriented framework like HIPAA or SOC. You have to have lineage of all of your migrations, so it's important to make sure you've got that in place. Um, Another big issue is tool first thinking. So DBT is not a strategy. Airflow is not a strategy. Um, Picking just the tools because they're the cool, sexy tools on the market is not a great idea because it's not a strategy, right? It doesn't produce a culture or a long-term idea, a long-term strategic growth process for your data team. So I think it's important to bring concepts to the table, which is another reason I think we're a strong fit to do this work, is that our software engineers all are very principled people. Obviously, we'll do what we need to do to solve the problem at hand, but we do like to think more strategically than I'm just going to use this tool to get this job. Granted, there's time to do that. There's time to, just get it done. That's fine. That happens. But you don't want to spend too much time just getting it done because then you have no repeatable strategy to optimizing what you're doing, right? It's not about having a strategy for strategy's sake. It's about optimizing and getting telemetry and saying, how do we get better at this? You can't get better at anything if you're just doing things all day long and not thinking about it, right? You can't get better at a sport or an instrument if you just noodle all the time. You have to have a focused practice ideology in order to get there. Next one, I think siloed teams is a big issue. And siloed teams, I think there's a world where software engineering and data engineering should overlap and design patterns and practices should happen. There's obviously certain pieces that belong solely to a data engineering team when we're talking in terms of lake houses and delta lakes and medallion architectures and things that, again, the data team is there to service the business and to provide insight into the business. But that data comes from somewhere. And if there's no good way to cross collaborate and cross pollinate your ideas with the people building the OLTP stuff, assuming you don't have a bottleneck in your system where you have one team that sort of defines and identifies all data, then you're going to run into some conflicts and some kinks in the system. So you want to make sure that you don't have teams that are just throwing things over the wall, right? Where the software engineering team shoots over events, right? We're just putting things in on a Kinesis stack and saying good luck, have fun, and the data teams are like, okay, great, what do we do with this? It's terrible. There needs to be data governance is really the word that you use for this that you see in big enterprises is the data governance strategy of how do we make sure that the data we're producing serves the business. But I would argue that in 2026 we don't want to over engineer that and put ourselves into a position to where we're just covered up with process and we can't get anything done quickly. I like to think iteratively and quickly and do things fast and simple, which is why I think that our software engineering expertise lends itself well to this. So kind of again to wrap it up, this is a little bit of a commercial, but I'm excited to start doing more of this work because it is work that I've done. It's work that I enjoy and I'm passionate about and that really defines the DNA of Seven Factor as a company. We've been doing this work for the past 9 years, but we've not been talking about it, and it kind of makes sense now to talk about it. We've been given the opportunity at some existing clients to do some data engineering and to grow this practice to grow this line of business for us. So I'm excited to do this, and I'm happy to continue to talk more about data engineering as we grow the business and also as we continue to do great work for the customers that we've already done. There's a lot of really fun and interesting problems to solve in 2026, especially with respect to real time and sort of the freshness of data and how real time is becoming more and more of a thing that we have to deal with on the day to day, as opposed to back when I was doing this, real time was a bit of a fairy tale because it's just too hard and there's too much data and it's too expensive. So it's exciting. I'm happy to introduce Seven Factors data engineering practice to our clients and our customers, and hopefully we can help you. If not, obviously we're amazing at software engineering. We're going to keep doing that and keep applying ourselves to those problems. But I'm also happy to apply those patterns and practices that have been so successful for us to building great data platforms for our customers. And that's it for me.